We've talked about the good types of sampling already: the simple random sample, stratified sample, cluster sample, systematic sample. Now we want to get into some types of sampling that you want to avoid. So we want to avoid bias in our sampling. And sampling bias occurs when the sample collected from the population is such that some members of the population are not as likely to be chosen as others. You're leaving out a certain group of people, either purposefully or on accident. And when you have this sampling bias, when you're leaving out a whole group of people, then you can have incorrect conclusions because you've left off a whole swath of the population. But if we use those random sampling methods from before, again, the systematic, the stratified, the cluster, the simple random, we should be able to get a result that's good, that does represent the population. And again, keep in mind, there is going to be variation in our samples. We could take a simple random sample of 20 students today, find their average GPA, take a random sample of 20 students tomorrow with the same method, and then another sample of 20 students the third day, the same method, and we're going to get slightly different results. I mean, I would expect them to be close together, but those averages will not likely be the exact same result just due to variation in samples. We would also keep that variation in mind with our calculations in the future. Now, we've mentioned the types of sampling that we like. There are a couple of types of samples that we want to avoid. The first that we should avoid is convenient sampling. That's going to lead to sampling bias. That's when you just ask the people who are conveniently around you. It's convenient to just stand in one spot, get the first 50 people that come by and ask them the question. For example, say if we want to know, should we extend the hours at the library? Should the library at TCC be open later into the evening? And so say we go stand in front of the library about an hour before they close and ask the first 50 students that walk by, hey, would you like the library to be open longer into the evenings? That's going to lead to sampling bias because, number one, we're standing right there next to the library with people going into the library when it's going to close in the next hour. So those people are probably more inclined to want the library to be open longer. And it's an easy sample to get. It's convenient, but we're going to get some bias in there because we're leaving out entire parts of the population. What about the students who go to the library first thing in the morning? Well, it's really not going to affect them if the library is open later at night because they're not there at that time. Or students who never even go to the library, that it may not matter to them if the library is open longer or not. They're not going to go regardless. So we'd want to randomly sample the population to get an idea of what everyone thinks, not just those students going into the library when the library is about to close. It's just a convenient sample. It's going to lead to sampling bias. We also want to avoid voluntary response sampling, where people in the sample volunteer to participate to give their information. There are two clear examples that I can think of off the top of my head. The first would be those comment cards that you see in restaurants. You're sitting at a table, you see a comment card over to the side. How was your server, rated 1 through 5? How was your experience, 1 through 5? How was the food, 1 through 5? Usually you don't fill those out, but if you have a really bad experience, then you're more inclined to fill one of those out. Or same thing, if you have a really good experience, if you get a free appetizer, if the person serving you is your roommate or a relative, you might be more inclined to fill one of those out and give the person a good review. But if it's just your typical everyday experience, you're probably not going to fill out that voluntary response card. As well, ratemyprofessor.com is a voluntary response survey. You don't have to go there after every one of your classes and rate your professor. Some people do that, but for the most part, people only go there when they have a really bad experience or just a really good experience, but the typical experience doesn't get recorded there. So we're leaving out what's typical and just getting those extreme results, the really bad and the really good. So we get some biased results there. And we'll wrap this video up with just looking at some examples, determining the type of sampling that's been used. So A says a polling agency interviews all math professors from 5 randomly selected colleges in Florida. In the Florida college system, there are 28 colleges, and this polling agency is interviewing all math professors from 5 randomly selected colleges. This would be a cluster sample. So we split the population of all math professors in the state of Florida into clusters by their 28 colleges. And then we're randomly selecting 5 of those 28 and talking to every single math professor in those 5 colleges. Therefore, it's a cluster sample. B, we just talked about. We talked to the first 50 students entering the library to find out their thoughts on extending the library's hours. That's not a random sample. It's not a good sample. That's a convenient sample. C, an advisor randomly selects 75 freshmen, 65 sophomores, 58 juniors, and 49 seniors to examine study habits. Freshmen are the largest group on campus, and seniors are the smallest group. This is a stratified sample. We'll take the population of all students, breaking them down by their year in school. So we're breaking them into strata, and then we're picking a certain number from each of those groups. So not the entire group getting picked, but just a few from each of those groups, and it's proportionate. So the larger group has the largest number selected, and the smallest group, the senior group, has the smallest number selected. D is a systematic random sample. City Council picks every 75th name from the phone book to sample residents to obtain data about moving power lines underground. And then on E, a division dean uses a computer to generate 50 random numbers and then pick students whose IDs correspond to those numbers. So it is a random sample. It's not systematic. We're not splitting into groups, so it's not cluster or stratified, but this is a simple random sample on E. So just to go through, A was cluster, B was convenience, C was stratified, D was systematic, and E is simple random.